Welcome back students. In this video, I'll be explaining about sulfonation of benzene along with its step-by-step mechanism. I have already made a detailed video on nitration of benzene where I explained about step-by-step mechanism involved in nitration of benzene. So nitration of benzene is also an aromatic electrophilic substitution reaction. It involves 3 steps. First step is generation of electrophile. In the second step, the generated electrophile, it attacks on benzene ring system and results in the formation of carbocation. In the third step, deprotonation of carbocation occurs to give corresponding substituted product. So these are the 3 steps involved in general in any of the electrophilic substitution reactions of benzene. When it comes to sulfonation reaction of benzene, it is also a type of electrophilic substitution reaction, but it requires an additional protonation step in its mechanism. Now let's see how the mechanism involved in sulfonation of benzene is little different from that of the other electrophilic substitution reactions of benzene. So here benzene reacts with concentrated sulfuric acid and it gives benzene sulfonic acid as the product. Upon reaction of 2 moles of sulfuric acid, there will be generation of sulfur trioxide. So this sulfur trioxide will be acting as electrophile and it will be further attacking the benzene ring system. And thus it finally results in the formation of benzene sulfonic acid. Sulfur trioxide, it consists of 3 oxygens. So these oxygens are electronegative in nature, due to which the bonded pair of electrons which are present between sulfur and oxygen, they will be more distorted towards the oxygen, thus creating partial positive charge on the sulfur. The sulfur of the sulfur trioxide is becoming electron deficient. It acts as electrophile and it attacks the benzene ring system in the second step. Now let us consider the details of the mechanism. Upon reaction between 2 moles of sulfuric acid, they results in the formation of sulfur trioxide, bisulfate ions and hydronium ions as the products. The formed sulfur trioxide, due to electron deficient sulfur, it acts as electrophile and it attacks on benzene ring system in the second step. The formed bisulfate ions, because of its nucleophilicity, it will be acting as base in the third step. So when the reaction occurs between sulfur trioxide and benzene, there will be formation of corresponding carbocation. But the carbocation which is formed in the sulfonation reaction of benzene is somewhat different from that of the carbocations that we get in other reactions of benzene. Because usually carbocations in other reactions, if you see, the carbon of benzene ring will be holding the positive charge and there is no other charge. While in this case, because sulfur trioxide charge-wise, it does not possess any charge, even though it is having electron deficiency due to electronegative oxygens. So, when such molecule attacks on benzene ring system, benzene has to give its lone pair of electrons to make a bond with sulfur trioxide. So, when a neutral molecule is getting excess pair of electrons, obviously it will attain negative charge. That's why we keep negative charge on sulfur trioxide. Because one of the benzene carbon is losing its electron pair, one of the carbon of benzene attains positive charge. So we will show positive charge on ring carbon and negative charge on sulfur trioxide group. So once carbocation forms, the immediate step is reaction with base. So the bisulfate ions which are formed in the first step will be causing abstraction of proton from the carbocation. So these bisulfate ions, they will take up these protons and thus they will form sulfuric acid as one of the byproduct. Now when you remove these protons, the bonded pair of electrons will be now transferred onto the ring system so that positive charge is compensated. So that is how we get C6H5SO3 minus as the product. Usually in the third step, we get corresponding product. But in the sulfonation reaction, we are getting a product which is ionic form, because here we are getting C6H5SO3 minus. Ions are unstable. So that is the reason immediately formed C6H5SO3 ion, it will react with the hydronium ion which is formed in the first step. So there is formation of H3O plus ion in the first step now. So it reacts with that. So this hydronium ion dissociates to give H plus ions and water molecule. So the liberated H plus ions will be taken up by this SO3 minus because it holds negative charge. So it will take up the protons from the hydronium ion. And immediately it gives corresponding substituted product, that is benzene sulfonic acid. So that is how the substituted product benzene sulfonic acid will be formed in the fourth step in this sulfonation reaction. So unlike the other reactions where all other electrophilic substitution reactions of benzene, they involve only 3 steps: electrophile generation, attack of electrophile, then deprotonation. But in case of sulfonation, there will be an additional step where the resulting product in third step is not a stable product, but it is ionic form. Hence, it will undergo protonation in the fourth step to give corresponding benzene sulfonic acid as the product. So in this reaction also, formation of carbocation is a rate determining step, and hence it is slow. And the reaction between carbocation and the bisulfate ions, because it is the reaction between two ionic forms, it is a fast step. I hope by this time you might have understood the mechanism involved in sulfonation of benzene, where in addition to the 3 usual steps in an electrophilic substitution reaction, this particular reaction involves an additional protonation step. If this video is useful to you, then give it a like, subscribe my channel so that you won't miss my next coming chemistry concepts. Thanks for watching. Stay tuned to my next video.